moduli finds a moduli for a transform length. But that's something that we're trying to find is a particular transform length. We don't know what this is yet. So we don't know what to pass to my find suitable moduli function. All we know is that we want to multiply two numbers whose decimal length is this here. So we need a function that can convert the notion of n decimal digits to a possible base and a transform length that is less than a provided modulus. So the way we'll approach this is we'll compute a modulus. So a modulus, I think, and then to use the inequalities to filter out such moduli. And 3 will, I don't know, use magic and return the base and x form length. The problem is we have a little bit of recursion here. In one sense, find suitable moduli, this function requires that we know the length of the transform that we want to use. On the other hand, we can't know that transform length without knowing what base we want. So this base right here and the transform length and the modulus are super tightly coupled. These two things kind of depend on each other in some sense. So we're going to need to do some search that's somewhat informed. We'll see if we can start, let's just see where we go with it. That's my plan. So let's look at this. All right. Let me make sure this window's open over here. All right. So I have these functions from before. I'm actually going to, I think, take them out just because. So let's look at the modulus computation functions real quick. Where are they? Let's look at the print suitable modulus. Print suitable modulus, or moduli. So if we have a transform length of 1,000, then some moduli that satisfy this are, here. So if we have a transform length of 1,000, 65536 plus 1 is an appropriate modulus that we can use. So what I would say is that we instead choose a number. Okay, so I think I know how I'm going to go about this. Let me get my tablet again. There's something else to this constraint right here, which I wrote right here. We can kind of chain this together and say that this should be less than 2 to the w plus 1 minus 1. So what we can do is select some nice numbers up here to create some candidate n's and b's over here, and then we can use that to generate a modulus. So we're going to try to generate n and b and then generate a modulus from that. So let's try that, see if it'll work. So let's start with the number of digits, which we have, and we also need the width of our word, which is this w. we can actually write it like this, I think. W word width is, by default, 64. 64-bit platform is reasonable, I guess. Number theoretic transforms don't actually work well when you're on a 32-bit platform, only because the number of moduli below there's only a couple of them that you could viably choose. So, yeah, let's go about this. So, finding a candidate. How do I go about this? We want to find candidate n and b's. Find candidate. Sit up a little bit. Find candidate transform lengths. Transform lengths. And bases b to do multiple. So, so the result, like I said earlier, of a multiplication of two num digits numbers is going to be twice that. So let answer digits is 2 times num digits. So this is the number of decimal digits that'd be in the result, plus or minus. 2 times num digits is definitely an upper bound, I believe. So if we have that many digits, then we want to know how many digits that would be in base B. So let's define a function with let digits in base and B, so many base B digits does it. And this is going to be approximately the log, I guess, the log of, let me think. So let's see, if 1 decimal digit in base B, so we want to go from some base BI to another base, or B1 to base B2. And the number of decimal digits that you can represent, and presumably this is going to be greater. Or sorry, it's going to be less than, because this is mostly going to be 10. So how many digits here does it take to represent a decimal digit here? Well, 1 digit in base, so 1 digit in base B sub 2 can hold, I guess, B sub 2 divided by 10 digits. So I think it's actually that simple. So it's not a log, it's just divide, or we multiply times n, divide that b by 10. So I think that's it. So for example, well, I guess we'll just see as an example. So the answer digits is going to be that, and we want to so this will calculate, the result of this will be capital N. So and we only need to, oh, N is also, I forgot, this is a very important constraint. Let's write it here. This is getting a little bit messy. N is a power of 2. This is important for our search. So, so this is really equal to 2 to some number L. So we can start by looking at different powers of 2 and choosing different bases to satisfy that. So we're going to loop through we're going to loop through n, because n has fewer candidate choices. So if n is 2 to the L, so for L from 1 to whatever our word size is, so to 64, I guess. Let's see. So we need to ensure that how do we say this? Let's calculate for n equals expt 2 to the L. And what would our b be? For b is going to divide, basically this is solving for b right here. So if we have, let me erase some stuff. If we have n times b minus 1 squared equal to some k, then b equals, well, k over n square root plus 1. So, but what's our k? Well, k is supposed to be our modulus. So it needs to be something around that, but like we said, we're going to search for things within our word length. So the language is Common Lisp. I'll show you that. I don't know, I think there's a stream delay. So b is the square root of n divided by our k, which I said is k equals question mark, and then plus 1 plus this. So when we have a candidate b and a candidate n, then we want to find a suitable modulus. So find suitable modulus. Let's do for m equals find suitable modulus, or moduli, and our transform length is now purportedly n, and we'll just do a count of 1. So find 1. So when what language is your primary work? My language primary at work is actually Common Lisp. I also program some C and a few other languages, but right now I'm mostly programming in Common Lisp. And do I do math-based programming? Some of it, yeah. Not all of it, but some of it is math-based, yeah. Equals 1 minus e2 to the word length. So we need to ensure that our modulus is less than the max word. Do return value. If m is less than our maximum word length, then we're okay. So we can return our base, our length, and our modulus. Let's see where this takes us. We still didn't specify a k,